Lastly, let's see how to do the p-value. Okay, so the p-value is here. Let's review the definition of p-value very quickly. In a hypothesis testing, for an observed value of the statistics, in this example, we're going to use sample mean. For observed values, the p-value is the probability of observing a value that is at least as extreme as that observed value, under the assumption that the null hypothesis is true. So, if our null hypothesis is true, what's the probability for you to see that value or even more extreme values? That's p-value. So here, we gave you one example. Our null hypothesis is saying that our mu is 1000. And then we have all these experiments and we say we get a sample mean that is 963. Then we say we get the p-value that is 3.2%. Okay, the graph is here. We get 963. This is a value, and what's the probability for us to see it or something that is even more extreme? Okay, so that's 3.2%. Let's see how to use Excel to get that 3.2%. So actually, it's easy. We have the setting here. Our population information, mu is 1000, sigma is 200, and you don't need to know the distribution because your sample size is greater than 30. It's 100 now. Then we have our sample mean distribution. Just like previous videos, mu is still 1000 according to your population mean. And your standard deviation for your sample mean is 20 because it's 200 divided by square root of 100. And then lastly, now we can say our sample mean is normal because we have central limit theorem. N is greater than 30. Okay, so the last step is that we do sampling and get a sample mean that is 963. What's the last step? The last step is just a single function call, normal distribution. This function, this has been used for many times in the past. We just need to tell the function what's the mean of our normal random variable, what's the standard deviation for that, and say that I want to get a cumulative distribution. Then just tell my function what's the cutoff value that with respect to that, I want to get the left tail probability. So I'm going to get the left tail probability of 963, right? That's why here I put 963, and that's why I get 3.2. So I may change this number to any other numbers you like. For example, what's the probability for you to see 900 or even smaller? It's going to be less than 3.2%, right? And actually, it's very small. What's the probability for you to see 980 or smaller? Well, that's 15.8%. Of course, maybe you are doing a one-tail test, or maybe you're getting, for example, 1,800. Oh, in this case, your p-value need to do a simple tiny adjustment. What's that? If you get 1080 as your x-bar, then here, the definition of being more extreme should not be your left tail probability. If it's 1080, being extreme must be at the other side. Means that you are calculating the right tail probability. So if this normal distribution function is giving you the left tail probability, then here you do a 1 minus thing to get the left tail probability. Okay, that's how you get a small number like this. So whenever you're getting a number that is above your population mean, then you need to somewhat use a different function to do p-value. You get the left tail, and then you use 1 to subtract that. You get the right tail. Or if your x-bar is lower than mu, then just that function call. But anyway, as long as you know you are calculating tail probabilities, then you're done. And as long as you know how to interpret your p-value, then you can do all kinds of hypothesis testing. Like previously, when this is let me take it back. Like previously, when we have 963, we say that, well, roughly speaking, the probability for seeing that when our population mean is indeed 1000, the probability of seeing this value is not small enough, so we don't reject H0. If this number is smaller, let's say 920, then this number is so small. What does that mean? If your mean is really 1000, it's almost impossible for you to see this value. Then we somewhat believe the mean cannot be 1000. Okay, so that's the whole idea about p-value. So again, if this is 960, well, it's somewhat possible. But as long as your p-value is smaller than your alpha over 2 in a two-tailed test, then we say, that probability is too small. If this is 980, well, you even have more than 15% probability to see this outcome. You don't consider it as weird, or you don't consider it as rare. It's possible. It's just possible. So you won't conclude that your process is wrong when you see 980. 980 is not small enough because its p-value is too high. Okay, so that's p-value, and that's how you may get p-values.